The second video for this module covers data tidying in the ActiveDuty Marital example. The tidyr package is what we'll use. So tidyr is meant specifically to help you create tidy data. And just as a reminder, tidy data is when each variable is a column, so each column has only one variable, each observation is a row, so each row is only an observation, and each value is a cell, meaning that each cell is only a single value. And once you've imported your data, you've done the work to figure out dimensions and some of the data descriptions, so what is the unit of observation, then you're going to examine to see if it's tidy. So if any of the answers to these questions is no, then you're going to want to tidy your data. Let's try an example. So go ahead, pause as much as you need, and look through these data sets. Which one do you think is tidy? I'll give you a second. The answer is Table 1. Now looking through each of these, Table 3 down here has two values in the rate column. So these are separated by a slash. That means that there's two different variables in one column. It can't be considered tidy. Table 2 has two different variables under the type column. So cases and population here. So therefore it can't be tidy. And you might notice that Table 1, which is the tidy option, also has two different years under year. The difference is that year 1999 versus 2000, 1999 and 2000 both represent the same thing, a year, whereas cases and population are distinctively different types. And we're going to go through this more in the R code. So let's say you have data that you've determined is not tidy. The way that you make it tidy is through pivoting. So pivoting allows you to change your data format without changing any of its values. You can pivot longer, and that function has the arguments of cols, which is the columns that you want to pivot, names to and values to, or you can pivot wider, names from and values from. And we're going to go over this in our R example script. So here I've replicated each of the tables that you just saw in the example. So table 1, you'll notice here that rather than typing out 1999 and 2000 three different times, what I did is I used the rep function. So it's going to pop out 1999 followed by 2000 three different times. And for all of these, we have the various variables. So country equals C, and then all of the names in the vector, and so on. So let's pop this into our environment. And what we can see, table 1 looks like this. So we have country, year, cases, and population. Table 2, country, year, type, and count. And again, type has two different variables within it. And then table 3, we have country, year, and rate has two different values in it. So you might wonder why table 1 is considered tidy when each country is spread across two different observations. So here we have Afghanistan 1999 and so on, and then we have Afghanistan 2000 and so on. So it would be relevant, it'd be valid if you thought, oh, let's break up year. And let's try that. We can use pivot wider. We're going to take names from year and then values from the cases and population columns. And let's see. What we get is cases and population split across two different columns, and we don't really want that. When we think through this data frame, instead of just having Afghanistan as the individual unit of observation, it turns out that the unit of observation is actually a country in a specific year. So Afghanistan in 1999 versus Afghanistan in 2000 are two different observations. So just because year, for example, has two different values that keep replicating, it doesn't necessarily mean that that column needs to be broken up. Table 2 is a bit more clear. So if we look back to table 2, clearly cases and population mean two very different things. We can use the same format. So pivot wider, we're going to take names from type. So we say here we want cases and population to be their own column, and we're going to take the values from count. So let's run this. And that looks a lot better. Again, we have Afghanistan 1999 versus 2000. Those are two different observations. So it's fine for Afghanistan to be in our data set multiple times because, again, the unit of observation includes the year as well. Now here, table 3's issue is that it had two different values under the rate column. And so we want to separate these out. What we're going to do is use the separate wider delim function, and you're welcome to look that up by deleting the first hashtag here. And what we're going to do is say that columns is going to be rate, the delimiter is that slash, and that we want the names to be cases and population. So we separate a column based on the specific delimiter. In this case, it's that slash. And we also want to tell separate wider delim what the new column names will be. So let's go ahead there. And now we see that we've separated that single column out into two separate columns. So now all of this data is tidy. Our next example uses the livestock dataset, and you can download this under Canvas under the Describing Data and Tidyverse and Data Tidying module here. So let's read this in. Again, I have it in my data folder, so we're going to source the root working directory with here. And now we see livestock in our environment. And this has lots of different columns and over 82,000 rows. And again, you can either click on it up in here or you can type view and it will pop up so you can see the full data. Looking through this data, the code column, so domain code, and then also flag, don't really give us any new information. So these are columns that we could do without. What we're going to do is we can reduce this data set. So we're going to create a new one called livestock reduced, open up livestock, and then we're going to select everything that does not contain code and that does not contain flag. So again, contains helps us sort out the columns that we want to keep or not. Looking at livestock reduced, now we only have 7 columns that make a lot more sense. But domain, element, and unit, domain, element, unit, they look to just be the same value repeating over and over again. We can check this using ndistinct, and we see that domain only has one value, and same with unique, it only has that one value of livestock. So we know that that's not really that helpful. And I can also use summarize to calculate all of these at once. So I can calculate the number of distinct elements in domain, element, and unit, rather than doing that in different lines. And what we get is that there's only one for each, so they don't really help us. Let's remove them. Again, the same thing here, livestock reduced, we're going to keep the same name, open up the data frame, then select everything that is not those columns. And let's look. Now we just have these 4 columns that make a lot of sense. We can arrange by year. So now 1961 comes first. And we can see that there's multiple items spread out across multiple rows. So the animal type item seems like an important variable. We can pivot wider so that each can be its own column. Going to follow the same process we used above. Pivot wider, we're pulling the names from item, and we're going to pull the values from the value column. So let's do that. And we see now each column has its own animal type. And our data went from having 4 columns and 82,000 rows to 11 columns and 13,000 rows. You don't always have to take steps like this. It really just depends on what your question is. If you think that each animal type is important enough to have its own column, you can easily pivot wider. But sometimes you might want to visualize and you might want to have everything collapsed into a single column. We can also pivot longer, and this is an example that I pulled from our textbook. We're going to use the Billboard data. Over here, we can see that that's song rankings for the Billboard Top 100 in the year 2000. And again, make sure that you go through each of these columns on your own. Essentially, it gives us the artist name, song name, the date that the song entered the top 100, and then the rank in each of the 76 weeks that this data set records. So the unit of observation here is an individual song. Here, what we can do is we can pivot longer so that week isn't spread across so many columns. So right now, week 1 through 76, and let's go ahead and view that here, each has its own column. That might not be necessary. And so what we can do is pivot longer. Here we're going to select all of the columns that start with week, and that way you don't have to type week 1, week 2, all the way through all of those weeks. We're going to convert the names to week and the values to rank. So let's go ahead and do that. Let's look at billboard long. That makes a lot more sense. So now we just have everything condensed into that week variable. And this is helpful because now we can answer questions like how long each song stayed on the chart. What we can do here is we're going to create a new data frame using billboard long. We're going to filter out everything that is NA. So there's entries where the song is not charting, that's listed as NA. We'll filter those out. We're going to group by artist and track because we want to be able to see both in the information that we use summarize for. We're going to summarize the count of weeks. So weeks equals N is going to give us how many weeks this song is charting. We're going to drop the groups, and then we're going to arrange in descending order on weeks. So let's go ahead and do that. And we're going to look it up here. Weeks on chart. Now we can see that. So Creed Higher was on that chart for 57 weeks. Lone Star Amazed 55, and so on. And if we want to check the top, we can do head. And if we want to check the shortest songs on the chart, we can use tail instead of head. So that's some examples of pivoting wider and longer. Let's go back to our example. So our next example is the ActiveDuty Marital example, and it's going to pull together data import, data transformation, and just a little bit of data tidying. And what we have here is a really, really messy Excel sheet. And I'm going to pop it up here too. You can see there's this column that's completely empty. Then we have pay grade, but in pay grade there's totals. We have this row, so single without children, single with children, and so on. But then it's followed by male, female, and total. This is a mess. There's a lot going on. We've got top of page down here, a lot of blanks, and then also it's similar across these different tabs. We're just going to focus on the first one. But when we look at this, there's a few different steps that we have to take to work through this file. The first is we have to figure out those grouping categories. So here, instead of single without children and then male below it, that doesn't make sense for the data format that we've used. So we're going to think through pay grade type, the different kinds we have, single without children. So we have male, female, single without children, convert those into their own columns, and so on. So pay grade type, pay grade level, marital status, parent, spouse affiliation, and gender are all the different categories that this data is representing. We're going to need to skip a bunch of rows, those white rows that don't really mean anything, and also the titles that don't mean anything. We're going to need to remove blank columns, and we're going to filter out the total rows. So let's go ahead and do that. Moving back to my script, let's pull up the ActiveDuty Marital example, and I'm just exiting all of the different data frames that we created. So moving here, we're going to use tidyverse, and we're going to use the here library. For this example, I'm going to run through everything with just intermediary data frames so that you can play with the difference. You can, run it and see the difference between them. And then at the end, I have a condensed version that does everything at once. So let's look at what happens when we read in this Excel file as is. You can see it's an absolute mess. We have NAs, we have columns that don't make sense. It's very, very messy. And that's why we have to be careful of how we read things in. The first thing we're going to do is create our own column names using delete for those that we want to remove. So delete for this column. And then we have ActiveDuty family. We're going to call that pay grade, pay level is that next column. Single, no kids, male is the next column, and so on. Just looking at the different groupings that we had in that original Excel file. And then we're going to use that rep delete at the end because there's 3 columns at the end that we want to delete. So we've created our names. And the idea is that we don't want any total column as well. So those are going to be called delete as well. Any column that we don't want to keep, we delete. When we read in the file this second time, we're going to read the file. We're going to tell it that we want the first sheet, which is total DoD, total Department of Defense. We're going to skip 9 rows, looking back here again, skip all the way until we just get that data. And then we're going to assign the column names to be the ones that we created ourselves. So Marital DoD looks a lot better. We have delete here for the blank column. We have pay grade, pay level, single kids, no male, single no kids male. Again, we had single and no kids, and then male in the previous rows. Single and no kids female, delete because this is a total row that we don't need, and so on. Now we're going to remove the blank columns. So we're going to create a new data frame called DoD select. We have Marital DoD. Select everything that does not contain delete. And then we're going to filter out anything in the rows that contains total. So looking at DoD select over here, we have columns like we have rows called total and listed, and we don't want that here. So we're going to filter that out. String detect detects anything that contains total, and what we're going to do is just filter everything that does not contain total. Now we look at DoD filter. It's looking a lot nicer. We don't have those NA values, and we have some columns that make sense, as well as no totals. And this is where we're going to transform the data. We're going to tidy it. So we're going to pivot longer so that we can separate the columns that represent marital status, kids and spouse, and gender. And we're going to say columns, all columns except for the pay grade, pay level. So looking at filter, all of these have single versus married, civilian versus military, and kids versus no kids, female versus male. We have all those categories. What we're going to do is for all the columns but pay grade, pay level, we're going to move the names to marital, other, gender. The name separator is that underscore that we created, and we want the values from count. So let's look at that. DoD longer. Now we have marital, gender, and then other being kids versus civilian status. We can also split up pay grade and pay level. So here, pay grade and pay level is actually 2 different columns. We're going to use that separate wider delim columns, splitting into pay grade, pay level, separated by that dash. And let's look now. See, now we have pay grade, we have the different pay level, we have marital, we have gender, and again, that other category that accommodates kids versus civilian status, and just a count variable here. It's a long way from this original data. Our next step is we can use case when to change the values of pay grade so that they make sense. So rather than having E, O, and W here, what we can do is create a new column, so mutate, and then case when pay grade is equivalent to E, we now want it to be enlisted. When pay grade is equivalent to O, we now want it to be officer. So that's the way that function works. Look at DoD mutate, and this looks a lot nicer. This is data that we can work with. We've separated out all the different categories that we can, and it looks way, way nicer. Now the condensed version of this, we can clear out here. What we can do is set those columns, and then we do everything at once, and we get the same thing. And that's it. That's an example of reading in some messy data and then tidying it a bit. This will be helpful when you work on reading in the railroads data in Challenge 2. That's it for this module.